reduced to x plus h, you can break that off as 5 to the x times 5 to the h. Right? This comes from the rules of algebra. If you have the same base multiplied together, you add the exponents, kind of doing it in reverse here. Everything else stays the same. And the reason why I do this, because we'll use this form later, there's a 5 to the x in both pieces. So if I factor that out, I get 5 to the h minus 1 over h. Nothing cancels, but I was able to factor out 5x. That may or may not have been immediately obvious from the start of this thing. It is what it is what it is. Remember, if I start off with letters in the question, I'm going to get letters back in my answer. Down here, we'll work with this later. But for now, this is the difference between this one. Let's do one more example, and then we'll stop here and let you guys go do some on your own. So true or false. I'm going to give you a function different than the one we saw, almost similar. This function, 1 minus e to the 1 over x, 1 plus e to the 1 over x, is an odd function. Now, a lot of people get this wrong, mostly because they forget what it means to be an odd function. A friendly reminder, an odd function is if you have origin symmetry. That doesn't help because you don't know what the graph of this function looks like, so we need the algebraic property that says if you plug in a negative, then the negative pops out. Think of like x cubed. Then the negative pops out. So that's really the question you're getting asked. You cannot look at this and just know the answer. This is a calculation kind of question. So our goal is going to be to plug in f of minus x and check, is it equal to minus the original function? I doubt many of us can do that in our heads. We have to work this out. So you shouldn't look at this and say, oh, it's obviously true or obviously false. If you want to sound fancy, hedge your bets, 50-50 shot. Let's see what happens if we work this out. Okay, here we go. So let's plug in everywhere that I see an x. I'm going to plug in minus x. And that's to all spots, numerator and denominator. Okay, so what is that? What's going on with that? How do I clean this up? E to a negative exponent. Say, is there anything you can do? Yeah, when you have a negative exponent, remember the rule, if I have like a to the minus n, it becomes 1 over a to the n. Negative exponents become positive in the denominator, so let's do that. Let's write this as 1 over e to the 1 over x, and then 1 plus e to the 1 over e to the 1 over x. So negative exponents become fractions. Now I took a complicated expression and made it into a complicated fraction. I have fraction over fraction, but that's okay. It's going to clean up. You say, well, is there anything I can do with this? Is there anything more to do? Well, you have fraction. You can think of it like 1 over 1. Fraction minus a fraction. What do you normally do when you have fraction minus a fraction? We simplify the fraction. So we have e to the 1 over x, e to the 1 over x. Let's write 1 with common denominator. 1 over e to the 1 over x. That's my big fancy numerator. All over e to the 1 over x, e to the 1 over x. So that's just a fancy way to write the number 1 plus 1 over e to the 1 over x. So at this point, and honestly, I still don't know where this is going. I don't know if it's true or false, but I know there's still algebra to do, and I'm hoping that something cancels. There's enough e to the 1 over x's in here that I'd like it to be true. Or at least I'd like to see something happen to tell me if it's true or false either way. Anyway, so let's subtract and add fractions. How does that work? Well, I have common denominators, so I add the numerators, and you get e to the 1 over x minus 1 over e to the 1 over x. And then that becomes e to the 1 over x plus 1 over e to the 1 over x. So fraction divided by fraction. So what do you do now? Well, this is a crazy exercise in algebra. You can keep, change, flip, right? You can multiply the top and the bottom by e to the 1 over x, and let's do that. So keep, change, flip, keep the numerator, e to the 1 over x minus 1, e to the 1 over x. Division becomes multiplication, and the denominator flips, e to the 1 over x, and you get e to the 1 over x plus 1. And now all of a sudden, because I'm multiplying, the e's to the 1 over x actually do cancel. Now, the last thing I'm going to do, because I want to know if this is negative f of x, I'm going to factor out a minus sign. So I'm going to get 1 minus e to the 1 over x.
Huh?
Now you can distribute the minus sign back in if you want to see it. You get exactly e to the 1 over x minus 1. And the denominator doesn't change. I'm just going to flip the order so it looks like the original function I started with. So now do you see it? So if you factor out the minus sign, you actually do get back the negative of the original function. This crazy road through algebra somehow works out somehow. You can graph this too if you want to see the symmetry on it, but if you don't have access to a calculator on a test or something like that, you have to work this out this way. So the answer at the end of the day is this thing not a function. This is true. Okay, this is a tough one just because of the algebra involved. Go over this example and the other ones before you start tackling the ones from the book or from the homework, and just get comfortable working with exponential functions. All right, great job. We'll see you next time.
差不多。